About another minute or so, we'll go over it. Okay, let's go ahead and go over it. And if try to do the same as last time, and just score it to the best of your ability. And I've also put point values this time because some of them had more than one item in here. And I noticed that like last time, if you got a 2 out of 3, that was pretty horrible. So I tried to add more items so that you have more points to gun from. So. All right, the first question is about a video we watched where people were passing a basketball from an elevator to each other, and we were asked to count how many times they passed the ball. And when they ran this study with people, about half of the people who watched the video didn't notice that a guy dressed in a gorilla suit walks through the scene in the middle of it. So the question is, why is that the case? Yeah.
Because we were given a task and our brains completely focused on keeping up with said task, and we basically started to ignore all the information that was being supplied to us.
Right. Okay. So goal-oriented and attending to a certain task. Anybody have anything different?
Working memory is mostly occupied.
Yeah, working memory. So anything about working memory, attending to a goal, attention. So this is a big thing about it's inattentional blindness is what this would be called. And the idea being that all of our attention is focused on a task, so even though this strange thing occurs right in front of us, we don't see it. Okay, so that segues nicely into question 2. Define working memory and long-term memory. Anybody want to define working memory? Yeah.
It's basically, I've kind of likened it to short-term memory. It's memory that we're planning on using either shortly or in that exact moment to focus on a certain task. It's basically going to be information that if you ask us to try and recollect a week later, we're not going to be able.
Okay, good. Anybody anything to add?
Said input stimulus.
Okay.
Like our immediate surroundings and how we see.
Yeah, so our perceptions of what's around us in that immediate state that we're maintaining would be in working memory. So it's limited. Yeah.
Combination of short-term memory and sensory memory.
Yeah, that's another good way to put it. So if you remember, we talked about short-term memory and working memory kind of being used interchangeably and also kind of not. Short-term memory involves a lot more of the sensation perception. Working memory includes that, plus a little bit of the ability to reference back to our memories and experiences. So long-term memory.
Part of memory where information able to be recalled is stored is infinite, so to speak, usually implicit and easily manipulated.
Yeah, okay. So long-term memory is where things that we actually commit to knowing are kept. We don't know that if it has any size limit. We don't think it does. It's not easy to put things in long-term memory. It's either through practice or through experience that things get put into long-term memory. But it's accessible, and once it's accessed, it's changed as it's accessed. So it adapts based on when you recollect. Anybody have anything else or questions?
Long-term memory is what memory comes to reinforcement.
Yeah, that's accurate. And so you can see that in a lot of conditioning studies and things like that, where people commit a stimulus response to long-term memory. Okay, question 3. Says assume that we ask someone to remember this list of items, and we've got a list of 7 items that are kind of like office-related stuff: pencil, paper, staple, tape, and then we've got a graph. And kind of what we're looking for is an approximation of the likelihood that each item is remembered. And so just across the bottom is the items in order. What kind of, yeah, go ahead and describe your graph, I guess.
Well, the 2 through 6, I just kind of put where I think that I would most likely remember them, but I put 1 and 7 as 100% because you're more than likely to remember the first item on the list and the last item on the list.
Right. Anybody? Yeah, like a U. Anybody remember what that's called? So remembering the first item is primacy, and then remembering the last item is recency. And then the overall effect is called the serial position effect. So just where the item is. Now there are some things that could be weird about that. Like when I was making this list, so I kind of tried to pick all office items. If I would have thrown in there like llama or something, and I would have put it in the middle, it's probably likely you would remember llama because it's different. So there's a lot you can do with this, but in general, yeah, I kind of want the shape on there. Okay, flipping over to question 4. So we talked about dual process theory and system 1 and system 2. So for implicit and automatic, is that 1 or 2? 1, yeah. Explicit and conscious? 2. Okay. Slow? Fast? Parallel? And serial? Okay. Good deal. All right. Next, the difference between an affordance and a signifier. So this is Don Norman stuff. Anybody want to take a swing at this?
Affordance is like what we think something does.
Right.
And a signifier is like where or how we would do it.
Yeah. So an affordance is something that an object kind of has just by existing, and the interaction of what we perceive and the object itself, that's the affordance, is just there. The signifier would be like a label, pointing that out to us, indicating to us, this thing can do this, or you can manipulate it this way. Questions about that?
Is using constraints okay to like describe that?
Yeah, definitely so. Constraints could be kind of either of those, an affordance or a signifier. But yeah, that's a fine way to explain it. Okay. Question 6. We've got 2 vending machines next to each other. And the question is one of them more cognitively taxing to use than the other? And explain why or why not.
So like the second one is like a drink machine, right? Like you click a button and
Right.
it's like got a picture on it?
Yeah,
Okay,
yeah.
that's what I thought.
Yeah.
So with that, I thought that the first one would be more taxing, or at least it is for me when I'm using it, because I have to remember the numbers
Right.
and put them in the right order.
Okay.
So,
Anybody? Any other? Yeah.
Is it also taxing because you have the ability to see all the different products, and because of it, because there's like more, you have like a hesitation to decide which one you want?
Yeah, definitely. Yeah, and in this case, like the little vending machines here, I guess the one on the left has more items in it for sure. Yeah, and I was hoping everyone would understand what I was intending with the second one, with that being the actual product itself. I did not have time to draw little Coke bottles or anything in there, so but if you didn't, just don't worry about it. Just give yourself credit on that if the visualization caused you trouble. So yeah, that's the main point. Also, what you could talk about here is, you remember Don Norman talked about mapping things and natural mappings. So like just pushing the thing that you want is like a pretty close mapping, whereas having to look at it, reference, and type it in is a little bit of an extra step. Okay, so if you guys will go ahead and give yourself a score or a question mark on that, and then pass them all to one side, I will pick them up.
I guess it'll pass.
You want me to take it?
Oh yeah. Oh wait, I totally did this right wrong.
Okay, I for a series burrito right now. 7 or 8 layers.
Oh wow.
I get a 7 layer burrito. The one that has the potatoes to it, so it's actually 8 layers. You know how they have like the potato taco? And then pieces of potato? And how you have the potatoes, and this actually is really good inside that taco.
That's all I know. All right.
Wow, I've never been to a Moe's.
Okay, so last time we talked about cognition and Don Norman. So, brief recap on that, which we kind of just did in the quiz. We talked about dual process theory, the idea of having a fast system and a slow system. Fast system just kind of automatically taking care of things. Slow system when you have to do more involved tasks like math or sorting things. We talked about kind of how cognitive biases impact HCI. And that it's important to provide people with options and clear representations and try to eliminate bias within interfaces and systems. And to kind of think of people and don't make them do the things that they're bad at. So then we discussed a bunch of what is best categorized as just Don Norman things. We talked about affordances and signifiers, with affordances being what something naturally in its environment is perceived to be able to do, and signifiers being kind of labels to direct us to see that. We talked a bit about conceptual models and how a user has a concept of how something works, how the system works, and that needs to map somewhat onto how it actually works. And we had this example of the refrigerator. That its inner workings were completely different than what the controls represented, and were not very intuitive or easy to remember. We talked about the 7 stages of action, and so this being that there is this gulf of execution and evaluation, and basically you start with a goal, you do a plan, you have a behavior, that affects the world in some way, and then you evaluate that and see how that compares to your goal. We touched on natural mappings, which we just talked about. So a classic example being stove burners and how the temperature controls are mapped to them. And we talked about slips and mistakes, where mistakes happen more in the goal, higher level thinking area, or the evaluation of an outcome. And slips happen in the actual performance of getting to a goal. And then we touched on the paradox of automation, and we talked about how when automation fails, it's often very difficult for a human who's out of the loop to get into the loop and understand what's going on and to help. So today we'll switch gears to what we'll call interaction design. And this is from a book called Interaction Design, Beyond Human-Computer Interaction. And we'll start talking about how you would approach designing a system or a product with users in mind, and kind of the principles and different methods for doing that. So we're going to start with good versus bad design. So what makes something a good design versus a bad design? And one way that's kind of easy to start looking at this, just without any knowledge at all, is just to take things that you use in your everyday life and sort them into things that you think are pleasant and good to use, and things that are unpleasant or not enjoyable to use. And so we're going to do a homework assignment. I'll put it out probably tomorrow, and it won't be due for at least a week. And it'll explain all of this. But what I'm going to have you do is submit 3 examples of good design and 3 examples of bad design. And so whether you can submit either a screenshot or video or whatever, and annotations on it to describe, what's good and what's bad. And so that'll kind of get you going down this path of thinking. So I'm going to share some of them with you that I pulled a couple of years ago, I think. So this was an example I thought of bad design. In this case, this is just CNN's website, and it loved to just autoplay the video. And in particular, I think this one liked to do it once you had started scrolling. So you couldn't just immediately stop it. So this is just a surface level frustration that I have using this interface. So that's all we're doing at this point, is just how do we feel about the interface? Not looking at any principles or anything, or studying anything in a formal way. So an example of good design, this is software called TechPad. And so if you've ever heard of, there's a typesetting language called LaTeX. It's basically a kind of a coding-like environment, and it outputs PDFs that are formatted in a particular way. So if you do publications for like journals or conferences, typically they all have their own little style guidelines, and so they'll write their styles into a file, and as long as you've written your article in this standard way, you can just apply their style to it, and it'll generate the PDF in the way that they like. So LaTeX is it's a full-blown programming language, basically, and it can be very complicated and very frustrating. But what was nice, I thought, about this software is that it does a nice side-by-side of your code and your rendered output. And you could also, click here, and it would bring you to the point here that matched that. And also is kind of giving you a nice little outline of the article that you're writing. So there's a bad example of something that I found frustrating, is that if you go to UPS or FedEx's website without having visited before in that session, just open a new private browsing session and do this, the first thing that they were asking at that time is, where are you located? And that's important for them, but they didn't even pre-select for you anything. And it's pretty easy to guess where a user is located. And it's not flawless. You should never just do this and not let them change it. But based on an IP address, you can usually make a good guess about where a user is, and then provide them a way to change that. Whereas this is just kind of always giving you this extra step, no matter what. So back to a good example. So this is an app. This is the iOS sleep tracking app. And so this mainly is just the visualizations are useful in this, showing you your time and when you're asleep, when you're awake. There are a ton of apps that do this kind of thing now. This one is the Spire, which was a little fitness thing, kind of like a Fitbit. I think it's still in business. I don't know. And so it would monitor your breathing and your movement, and kind of shows you a similar visualization, trying to give you this information in a digestible format. So the next bad example. These are robots at the last DARPA Robotics Challenge that was search and rescue robots. And so I actually got to go to this, and it was crazy to see how people were controlling and interfacing with these robots. So, like, if you look at this, you've just kind of got all the video feeds coming from the robot. You've got just a raw output of like the point cloud, the depth data that the robot's getting from its sensor, and people are just kind of like typing low-level commands to move things. And if you saw the DARPA challenge, you'll have seen these robots are very, very slow to accomplish anything. And they're being teleoperated by humans. In this case, this is such an impressive setup to me. Several computers, again, all the unstructured data feeds, these little just control surfaces that are very customized for this robot, which I think the Shaft robot did win the challenge. But this is kind of an example of an expert interface, right? Like this person who's operating this machine is very in tune with this thing, and this is helpful to them. But it's kind of just a disaster to the average user. And then a final good example that I pulled was it's an app, Daisy Disk, that just visualizes hard drive space. And it's useful because it gives you the nice pie chart thing. You can click on an area, and then it will zoom in on that, and now that's the level. It's really, really helpful for deleting files and reclaiming hard drive space, especially when you can't expand it on your own because of Apple. But so.
Is that visualization supposed to be like the tracks and whatnot on the hard drive?
I don't know. I'm assuming not, because it's it's just showing like root level folders and the next level. But yeah, that's an interesting point. That could be kind of confounded with that, right? Because traditional hard drive is a disk, and so that kind of fits that. Yeah, I hadn't thought about that. So that's maybe a downside of this visualization.
Or clever marketing.
Yes. So those were just some examples. I just wanted to show you those were just software examples that I pulled. You're more than welcome to incorporate hardware examples or really anything that's good or bad design. Just kind of explain why. So talking about good design, how do we get to a design that's good? So we just covered what we can think of as intuition or kind of self-testing. And that's based on building something and then using it ourselves and evaluating where it works and where it doesn't work. So this is pretty effective, especially if you as a designer are similar to the users you're designing for. But there do tend to be areas where we'll miss things. There are sometimes areas where we focus too much on things that don't matter to anyone else. And so relying completely on your intuition and self-testing is never really enough for a good design. So we have to turn to more principled approaches. And these involve basically one of two things. Either we're going to look at things that have worked in the past, look at these design guidelines, or we're going, and included in that we can consider how a human interacts with the world, all of the cognition stuff that we've learned about. That's all for us to consider when we're designing. The other part of that principled approach is to test and get feedback. So it's important when we're doing this to consider humans and what they're capable of if we're designing for a human, which in this class we're pretty much designing for humans always. And we will also want to consider the domain. So that seems pretty basic, but these are the things like, will this be used in bright sunlight? What will the temperature be like? Will the person be wearing gloves? What is the higher level goal that the person will have? You want to think about your user's characteristics. So for example, if you're designing something for kids, one thing to think about is that children of a young age don't have a lot of experience using a mouse as an input device, usually. So like, tablets have been great since they've become so widespread because it's direct manipulation. It's really easy for young children to map onto that. So one thing that is interesting that I can tell you, that recently I've seen my fiance's mother works in a school, like an elementary school, and she runs a computer lab. And so the kids all have to come in and do, whatever on this web software that the school has purchased to, evaluate their level of math and verbal skills and things. But when kids in kindergarten come in, there's one of her, there's 24 of them, and they've got to log into the website now. And the login is just their name, and they all have like some default easy password. But even just that task is very difficult. And you can spend forever trying to solve, get all those kids logged in. So if you were designing that system, you really got to think about that. You want to provide a mechanism that's going to somewhat solve that problem. And so that's considering both the domain being a school computer lab and then the user being a young user who's going to take some time and may need some assistance with certain things. So moving from just thinking about the user and where they're at, we can also involve users in design. So this is sometimes called human-centered design. Other times when you let the user make direct decisions about how the system will be implemented, that's called participatory design. And that is, you are basically there designing the system, you're sitting with the user, having them use it, you're getting their feedback, and you might be making changes right there with them to make it meet their needs. Okay, so interaction design itself. It's described as being this all-encompassing thing for interactive products. And so it's supposed to stretch beyond just usability is the purpose, is the main idea of it. So it's supposed to be an umbrella term that kind of encompasses all of these things: user interface design, user experience, user-centered design, interactive systems, HCI. For our purposes, it's fine to consider HCI as interaction design, as HCI as being the umbrella over all of this. Because if you look at the field of HCI and people who identify themselves as working in HCI, you're going to see all of these areas represented today. And so when we say interaction design, we just mean what we've been calling HCI this whole semester so far. So here are some of the fields that are involved in HCI or in interaction design. And so you can see any kind of engineering or social science. There aren't many fields that are excluded from this. So kind of to get us thinking about it, let's imagine we're creating a public kiosk that provides information about museum exhibits. So who would be involved in designing that system?
Be the curator.
Okay, so like the museum curator. Who else?
That's design the software kiosk runs.
Right, and so if you're, you could either be designing that software, or you could be trying to look at what does this kiosk vendor put together that I can use.
You gotta have the historians who know what information to put there.
Right. So that's kind of your domain experts. What about, where is this public kiosk going to be? It's probably going to need power. It's probably going to need to be able to, if it's outside, survive weather conditions or attempts at vandalizing it. You might need to think about security in terms of physical and cybersecurity. So the point being that there are a lot of people involved in this simple thing. So now kind of imagine creating an interactive website for a TV series. Who would be involved in that?
Web developers, artists, or having to actually design the website. So
Right. So you,
it coincide with the show. It's like if it's a cartoon, there would be a lot of cartoonish.
right.
The person in charge of marketing at the TV series, whoever's hosting it.
Yeah, whoever is controlling the brand and wants to make sure things are consistent.
They have to advertise the website on the show.
Right. So there's got to be a little communication feedback loop for that. Anybody else you can think of that might?
I have to do some basic security stuff too.
Yeah.
That's really crucial.
So yeah, and that gets into another area. So probably have a legal team that would be involved in some of this, right? Trying to make sure that whatever standards you have to meet are actually met. So the point being that there are a lot of different people involved in these designs, even for something relatively simple. And what's really important is that all of these people are able to communicate with each other in an effective way, and that all of their concerns are able to be communicated between everyone and to be addressed. So all of this is to create what we call a user experience. And user experience is a term that encompasses from the moment the user comes into contact with the system or product until the moment they're done with it. And it's focused on how they feel, what they like, what they don't like. And what's important to remember is you cannot directly design a user experience. So you can design for a user experience. You can try to make certain things happen. But you can't guarantee that a user will have a certain perception or reaction to the experience that you set up. You probably can come closest to this, if you're doing controlled lab studies, or if you're, running a theme park like Disney or something, and you can really tightly control a lot of things. You can almost guarantee a certain experience, but that's still with a probability. Because some users are going to have problems and going to have experiences that are different from other users. So when we account for user experience, this is kind of a framework that breaks it down into 4 areas. And it breaks it down to what it calls threads. There's a central thread, which, if you remember, we talked about Norman and the visceral level of perceiving things. And so that's kind of like just you look at something and it's pleasant, it's appealing, it's not aversive to you. There's an emotional thread, and so that's when the user's interacting, when they're in the experience, what emotions arise during that experience. Compositional thread is more of the narrative that the user will keep running when they're engaged in the task or engaged in the experience. So also this gets into like how a user makes decisions, how they remember things, some of those cognitive sides that we've talked about. And then spatio-temporal thread, which is how the experience affects the user's perception of time and space. And so kind of an interesting thing about designing interfaces, designing for these experiences, is that the perception of time is something that you can mess with a little bit. So we've all seen progress bars that may like shoot forward at first and then kind of hang out for a while and then shoot forward again at the end. It turns out it's a really good strategy to have the last part of it go really fast, because kind of that primacy and recency thing that we talked about, like remembering objects, people's perception of how long that process took is based on seeing the end of that. And so there's a lot of interesting research just on progress bars and how you can mess with how people feel by the way that you animate your progress bars or how you actually visualize that. But that's a really important area of the user experience. So I'm going to talk about 4 steps that are pretty uniformly applied to the process of designing for a certain user experience or creating a system. And these are very basic. So this is where we start to overlap with software engineering a little bit. And we say things like, okay, you've got to look and see what are the requirements. You've got to design alternatives, basically options to meet these requirements. You've got to prototype it, and then you've got to evaluate it. So we've discussed that quite a bit already. But this is also where you have to remember a lot about your domain and your user. And so one thing I think I didn't mention, so when we're talking about the user, if you're designing an application that's going to be deployed like worldwide, you've got to think about things like how do you format a date? Because in the US, we tend to format it with one order. We do month, day, year, whereas the rest of the world, not so much. They will order it either day, month, year, month, day. And so that's something in your software that you need to have support for. And so that's usually called localization in software. Also, things like reading, we read left to right in English. Some languages read right to left. And so when you have an interface that's going to be translated into a language that is typically read right to left, also you need to change the alignment of a lot of things. For years, Android had the back button on the wrong side whenever you're in a right to left language. And it's an artifact of not of primarily designing it for languages that are left to right and not considering the right to left. So that's something to think about. So user experience versus usability. So we talked a little bit in the history of HCI. HCI was initially worried about usability, function, efficiency, safety, utility, how easy is it to use. User experience is this other realm of things. It transcends this usability goal. Now we're talking about how people feel about using a system. We're using things like rewarding or satisfying or helpful, kind of emotion words. And so user experience, encompasses both of these, but usability is kind of assumed once you start to focus on this level of thing. So to touch on some basic design principles, and we touched on a lot of these when we talked about Don Norman's stuff, so we'll just kind of reiterate some of them. So it's important visibility. Obviously, whatever you're designing, you want to make it easy for people to find the functions of the things they want to do. They need to be visible and apparent, not hidden. This becomes more difficult as a piece of software becomes more complex and has a lot of functions. Feedback, and this is really, it seems so simple, but you'll find problems with it so many places. A user's action should have some effect on the world. Even if that effect is to say, hey, don't do that, or this doesn't do anything. You want to provide feedback, and you don't want to ever, on the more technical side of things, like you don't want to do work in a process that's going to like freeze the GUI layer or the graphics that are rendering, because then you're going to lose all of your feedback. And we've all experienced that where something's frozen, you're clicking. Now we even have the joy, like if you use a computer that has a trackpad that doesn't really click, it just does the vibrations to simulate it. Sometimes you can really mess things up to the point of crashing the little firmware running the trackpad, and now you can't even click. So it's always really weird, but that's horrible because there's absolutely no feedback. You literally cannot press on the thing you thought you could. But So feedback's critical. Constraints, we talked a lot about constraints. Basically, you want to do anything you can to show the user where to go. An example of this, too, is like graying out options in a menu so that the user, they need to know that that option exists, but they're not able to use it at this moment. So if we were to just remove it from the list, that would be very frustrating because it would sometimes be there and sometimes not, and the user may not realize why. So consistency also becomes really important. So within a system, making sure we have a consistent way of doing things. So, you know, whatever method you're using to delete something on one screen should be the same way to do it on another, unless there's some large mitigating circumstance. So, like, you can think of like mobile devices on iOS, for example. Typically, if you've got like a table view and you swipe to the left, you're going to delete something, and that's propagated throughout the entire system. And then affordances, we talked about with Don Norman quite a bit. So, okay. So, some basic design principles. When you approach a problem, kind of what's first? What do? Do you start to sketch out a proposed solution? Do you start to just code something directly? Do you talk to users? There's no real right answer to this. It depends on what you're doing, and it depends on the experiences you've had. So in most cases, it's going to depend on the scope and the size of the project. If it's something with a lot of users and that you're unfamiliar with, you definitely need to talk to users and experts and see what they're expecting and what they need. If it's something that you're already familiar with and you're an expert in, or that there's like a really narrow scope of people that are going to use it, you might just jump straight to sketching something or coding something. That's certainly not unheard of, and it can work. But for this, we'll talk about conceptualizing interactions. And in this case, we're thinking about larger systems that are going to serve a lot of users, and probably in a domain that we're not extremely familiar with, and it's not our day-to-day life. When we start to conceptualize like a problem space, when we're going to propose a solution, one thing that we really want to avoid is starting at too low of a level, thinking too much about very specific things like, you know, what UI framework am I going to use, or, you know, what color scheme, or how am I going to align this, or what animation is going to transition me between this or that. You also generally want to avoid being driven by the technology. You don't want to do something just because the technology can do it. Another important thing, especially when it's an unfamiliar space and you're working on a team, is writing down your assumptions. Because you'll have a lot of assumptions and you may not realize that you have them. And so enumerating those assumptions will help you see if there's something that you need a clear answer to, and maybe that's just asking someone in the domain to help you, or that may be testing something a couple of different ways. And one thing to remember, I guess, is relating to avoiding starting at too low level or letting the technology drive something. Just because we can do something doesn't mean we should necessarily do it. So one of the examples that the book gives is using a heads-up display in a car to, you know, play YouTube videos. We can certainly do that, but it's probably bad for the driver overall and the experience of the people in the vehicle. So we have to think about things like that ahead of time. So here are some questions during the design process that you can ask yourself or circulate among the team. So if it's an existing product that you're coming in to update or improve or something, you really have to learn what the existing product does, what problems it solves, because those problems won't be there, and what it's good at, what it's bad at, why you're there, what you're going to change. So And then you've kind of got to go through this typical flow of, what are the problems? Why are they problems? And then thinking about how you can overcome the problems. And trying to do that in as simple a way as possible. And so some problems may not even really require complicated interface work. It may be as simple as changing a process or an order of something. So I want to create a conceptual model of the problem space of what the user will be doing. So introduce some terminology here. So you can think about metaphors and analogies, concepts, and task domain objects, relationships, and mappings. So these are the kind of the 4 things to think about here. So it's very helpful to use metaphors and analogies when you're designing a new solution, especially. People tend to, somebody will explain something new to you, and they'll say, it's like, this other thing, but with something changed. That's really helpful because we can access the schemas that we already have for something we know well, and leverage that to learn something new. In terms of concepts and domains, so when we're creating this conceptual model, we need to be aware of what is it that the user interacts with. So is it, FedEx shipments? Are they interacting with package things, things that represent a physical package? Are they interacting with a video feed of something? What is it that they manipulate? So are they doing some kind of, 3D design where they're moving geometric objects around or drawing sketches? And you also need to think about the relationships between the concepts or the task domain objects. What are the constraints between the things that are being manipulated? What do they actually mean to each other for the user? And then finally, you want to map all of these concepts and relationships to how that affects the user experience. So a lot of conceptual models that are really good appear obvious. So they appear like things that's just like, yeah, that's obvious, but it's not necessarily obvious to develop them. As a product matures and more is added to it, you also have to develop this conceptual model. And so it can get a little bit complicated. So for example, how many ways are there to delete a file on just an operating system? There's quite a few. And that's okay. But users are probably functioning with different conceptual models depending on the way they're deleting that file. But as long as they have a model that works for them and it matches the system model, then that's fine. But as the product matures, more and more will accumulate there. So this is just an example of metaphors. So this is just a visual metaphor of something physical, like a calculator, on just a computer. The desktop itself is a metaphor for an actual desktop. But obviously, metaphors don't fully extend. So for example, you don't have a trash can on top of your desktop usually, but on the computer you do. We also see things like more recently, like Google for a while, and I guess they're still doing material design a lot, like having everything on little cards, kind of. So it's kind of resembling a physical index card that you might have somewhere. Okay. So I'm going to talk about a few different types of interactions. This will complement, we'll have a lecture or two on just different types of interfaces themselves. So this kind of goes hand in hand with that. But here we've broken interactions down into the phase where a user is instructing a system to do something. So this is usually a one-sided command, telling something to print or save or delete, something like that. There's conversing with the system, and so this is more of a give and take kind of scenario. So examples of this, chatbots, games with an AI component where you're doing something and the system is doing something in collaboration. This can also be things like voice assistants, but we have to be careful here because even though something's a voice assistant, a lot of times we're just instructing it. Set an alarm for 8 a.m. That's not a conversation. So that's where it kind of blends a little bit. The other area, manipulating. So this is just when the user is physically interacting with kind of those conceptual objects that we talked about. They are moving things around within the interface. And it is important to realize that we can't always have direct manipulation. So, things like a word processor or a spreadsheet, there are functions on there that you're not going to be able to do with direct manipulation. And then a final category that's kind of just this random tack on is exploring. So this is specific to virtual spaces and a user moving through and exploring an environment. Okay, so we're going to kind of conclude with looking at paradigms, visions, theories, models, and frameworks. So a lot there. But so in general, a paradigm we think of as kind of a set of standards that a specific community has adopted. So whenever desktop computing was kind of the big new thing, we saw this paradigm of WIMP, which is Windows icons, menus, and pointer. And so everything could kind of be designed and talked about in terms of that. Then once we pushed past the desktop, this couldn't quite cover things like touch interactions. And so that paradigm has to either change or a new one has to be adopted. Visions. So this is kind of the fun one. Visions are basically just considered this motivational, conceptual idea of the future that's supposed to drive technology and drive the future of design. We're going to watch a video of Apple's 1987 Knowledge Navigator, and it's wonderful. But the point is to provoke questions about future designs and needs. So, like all the research I do is in human-robot interaction. People don't have robots in their homes yet, aside from vacuum cleaners, really. They're not having conversations with them. It's a thing that doesn't exist in the world at a large scale. It's not affordable to do it. We're not good enough at it, though we certainly try. So, like, the things that I'm studying are largely trying to find future problems before we get to a point where we actually have them out in the wild. So I'm going to play this video from Apple. Let's see. And this is something they put together in 1987, so this is before the iPad and Siri. This is just remember. Ooh. Oh no. Let me see where my audio is. That is problematic. Give me just a second and I will correct this wrong.
There's no such thing as a perfect writer. This is why I use Grammarly to check my work.
If I'm putting
Yeah.
You have 3 messages. Your
Your graduate research team in Guatemala, just checking in. Robert Jordan, a second semester junior, requesting a second extension on his term paper. And your mother reminding you about your
Surprise birthday party next Sunday.
Today you have a faculty lunch at 12 o'clock. You need to take Kathy to the airport by 2. You have a lecture at 4:15 on deforestation in the Amazon rainforest.
Right. Let me see the lecture notes from last semester.
No, that's
not enough.
I need to
review more recent literature. Pull up all the new articles I haven't read yet.
Journal articles only?
Fine.
Your friend Jill Gilbert has published an article about deforestation in the Amazon and its effects on rainfall in the Sub-Sahara. It also covers droughts' effect on food production in Africa and increasing imports of food.
Contact Jill.
I'm sorry, she's not available right now. I left a message that you had called.
Okay.
Let's see.
There's
an article about 5 years ago. Dr. Flemson or something. He really disagreed with the direction of Jill's research.
John Fleming of Uppsala University. He published in the Journal of Earth Science on July 20 of 2006.
Yes, that's it.
He was challenging Jill's projection of the amount of carbon dioxide being released to the atmosphere through deforestation. I'd like to recheck his figures.
Here's the rate of deforestation he predicted.
And what happened?
And what happened?
He was really off.
Give me the university research network.
Show only
universities with geography nodes.
Show Brazil. Copy the last
30 years at this location at 1 month intervals.
Excuse me. Jill Gilbert is calling back.
Great.
Put her through.
Hi, Mike. What's up?
Jill, thanks for
getting back to me.
Well, I guess that new
grant of yours hasn't dampened your literary abilities. Rumor has it that you've just put out the definitive article on deforestation.
Aha. Is this one of your typical last-minute panics for lecture material?
No. That's not until
4:15.
It's about the effects
that reducing the size of the Amazon rainforest can have outside of Brazil. I was wondering.
It's not really necessary.
But
Yes.
It would be great.
If you were available to make a few comments. Nothing formal. After my talk, you would come up on the big screen, discuss your article, and then answer some questions from the class.
Bail you out again? Well, I think I could squeeze that in. You know, I have a simulation that shows the spread of the Sahara over the last 20 years. Here, let me show you.
Nice. Very nice.
I've got some maps of the Amazon area during the same time. Let's put these together.
Great. I'd like to have a copy of that for myself.
What happens if we bring down the
logging rate to 100,000 acres per year?
Interesting. I can definitely use this. Thanks for your time, Jill. I really appreciate it.
No problem. Next time I'm in Berkeley, you're buying the dinner.
Right.
See ya.
Dinner, right.
See ya. 4:15.
Bye-bye.
While you were busy, your mother called again to remind you to pick up the birthday cake.
Fine. Print this article before I go.
Now printing.
Okay, I'm going to lunch now.
If Kathy calls, tell her I'll be there.
If Kathy calls, tell her I'll be there at 3 o'clock.
Also, find out if I can